So literally, you can explain to your manager what's happening inside a decision tree classifier. And in this video, we will see it in action by solving a classification problem by hand. Let's get to it. This video assumes that you have the basic understanding of what decision trees are. If you are not sure or need a refresher, I got you covered. Check my previous video in the description below where I go through all the main ideas. Let's assume that we want to predict whether we want to eat out, symbolized as a delicious slice of pizza, or eating in, symbolized as an egg in a pan. And to do this classification, we want some inputs. For example, the weather. Is it sunny or rainy outside? Do we have some money to spare, or are we on a tight budget right now? We all can relate to that scary face. And finally, do we enjoy company today, or do we prefer to spend the night me, myself, and I style? So, to summarize, we want to classify this using these. The decision tree starts by asking the question that helps us gain as much information as possible early on. So it assesses the three potential questions as follows. If the weather is sunny outside, we go left. If it's rainy, we go right. So we start at our first data point. It is sunny, so it goes left, and we will keep a score of what class we have at each data point. Here, we have a pizza, so we add 1 to the pizza scoreboard. The next data point is rainy, so it goes right, and as we have a pan, we add 1 to the pan scoreboard. The next data point is sunny, so we go left, and we have a pizza, so we add 1 to the pizza. So in total, 2. Same with the fourth data point, fifth data point. Now with the sixth data point, it is sunny, so it goes left, but we have a pan instead of a pizza, so we add 1 to the pan at our scoreboard, and so on. This one, same here, and the last point. The decision tree assesses how pure this node is by calculating what is known as Gini Index. This index is a number between 0 and 0.5, which indicates the likelihood of a new random data being misclassified if it were given a random class label. The 0 means the node is pure, the 0.5 means it's impure. Its formula is simple. 1 minus the summation of the probability of samples belonging to each class at a given node is squared. Well, that doesn't sound simple, does it? Give me another chance. It's 1 minus the summation of the probability of a sample being a pizza squared and the probability of a sample being a pan squared at a given node. Things will get clearer in a minute. So what's the probability of a sample being a pizza at this node? That's easy. It's how many pizzas we have, 4, divided by the total number of samples at that node, which is 4 plus 2 equals 6. Similarly, the probability of a sample being a pan at this node is how many pans we have, 2, divided by the total number of samples at that node, which is 4 plus 2 equals 6. So we do the math and we end up with 0.44 as a Gini index of that node. And it means that this node is not pure, which is clearly the case as we have both pizzas and pans in there. So we will write it here and we will come back to that later. We will do the same for the red branch here. 0 pizzas over 4. 4 pans over 4. And we get a Gini index as 0. This means that the red node is pure, which is evident by having only one class in there, pans. So we will write it there and we will come back to it later. So the decision tree will jump to the second potential question to assess it. Do we have money to spare or are we on a tight budget now? And we will follow the exact same methodology we did in the previous steps. With us having money to spare, we have 2 pizzas and 4 pans. Here are the 2 pizzas and the 4 pans. And we calculate the Gini index as before. And we got 0.44. With a tight budget, we have 2 pizzas and 2 pans. And we calculate the Gini index as 0.5. Note how the Gini index here is 0.5, meaning the maximum of impurity. This happens when we have the same number of pizzas and pans at the same node. Alright, the decision tree will jump to the third potential question to assess it. I think you got the idea now. Now, after we calculated the Gini index for each branch, we still can't decide which question is the best in our case. This is why we need to calculate the Gini index for the whole node. We perform a weighted average as follows. The Gini index of the first branch, 0.44, times the number of samples at that branch, which is 4 plus 2 equals 6, divided by the total number of all samples at both branches. 2 plus 4 plus 4 plus 0 equals 10. And we will add to that the Gini index of the second branch, which is 0, times the number of samples at that branch, which is 4 plus 0 equals 4, divided by the total number of all samples at both the branches, the 10, and we end up with 0.27. We do the exact same thing for the second and third questions. So the first question gave us the lowest Gini index possible, meaning the lowest impurity possible, meaning that we gain more information by asking about the weather than either budget or enjoying company. So the decision tree picks it up as the root node. So as you can see that we ended up with one impure node, the green, and one pure node, the red. Let's focus on the impure node now, the green, and see what next question should we ask to make it pure. And since we are focusing on the sunny branch, let's temporarily hide the rainy data. So we will repeat the steps we followed above to decide what the best next question is. For unlimited budget, we have a Gini index of 0.5 and 0 for a tight budget, and the weighted average of this node is 0.33. For a social style night, we get a pure node as the Gini index is 0. For me, myself, and I style, we also get a pure node, so the weighted average of this node is 0. So it seems the third column gives us the lowest Gini index, and hence it's the best question to ask next. As we reach all leaf nodes as pure, there is no further action needed. Congrats, you built your first decision tree. But wait, decision tree didn't use this column at all. Yep, that means it's not important in this case. And I wonder where my money had gone. So the decision tree reveals that this column is not useful in this case. And this is one of the byproduct of using decision trees, which assessing feature importance and helping data scientists to select the relevant features. And that's it. If you like this video, please hit that subscribe button.